Hi, my name is Harry Parker and I'm a student here at JTech here in Jacksonville, Florida. Today we're going to be doing a video tutorial on the basic operation on using electrical diagnostic equipment. To do that, today we'll be using these two different types of digital multimeters. This one actually has an inductive clamp on it so that we can check for amperage. We'll use this one to check for voltage and resistance. The first thing I need to do before we get started is we need to talk about safety a little bit. Anytime that you're going to be working around an electrical system, you want to be safe, which means you want to wear some safety glasses to protect yourself from any kind of spark. Also, you want to make sure that you don't have any metal jewelry on your hands or any dangly jewelry that can get caught in any part of this and cause an electrical short. To successfully grasp the concept of doing multimeter operations, we're going to show you 4 basic tests that we'll be conducting today on this Colorado. We're going to be doing a source voltage test. We will do a voltage drop test. We'll do a resistance check, and we will also do an amperage test in that order. So let's go ahead and get started. The first thing you're going to want to do is anytime that you're doing any kind of electrical diagnosis, you want to start out and see what you have for source voltage, because you can't assume that this is a 12 volt DC automotive battery. You can't assume that it necessarily has 12 volts in it. So you want to see what you're starting with, and we're going to begin here with checking the source voltage on this battery, which is going to supply the power to the vehicle. So I'm going to put the red lead on the red side of the terminal, and I'm going to put the black lead on the black side of the terminal. And right here you can see that we are starting out with 12.05 volts of DC electricity. So that means that we have 12.05 volts of battery source voltage. We can go ahead and we can start testing the system using that as our reference. So with the key in the off position, we can go ahead and we can check the positive side of this battery cable, and we can trace it to here, and you'll see that with the key off we only have 2.8 volts on this part of the lead, and we have 2.7 on this side of the lead, which that's within normal range. So the next thing that we're going to do is we're going to show you how the normal operation of the vehicle, when you're beginning to start it, it actually changes and will start showing a decrease in voltage. Go ahead and turn the vehicle to the run position, but not start. We good? Okay, so now that the key has been activated and engaged, we come back and we check our voltage, and we have now gone, prior to even cranking it, we have gone down from 12.05 volts to 8.8 volts. So you'll see the difference of the voltage drop on that. Now the final step is go ahead and crank it. And now we'll see that the voltage scrolled through and began to drop. So that would be an example of how to do a voltage drop. Our next test that we're going to be demonstrating right now is just it's a simple resistance check. And for my example, what we're going to do is we're going to check the resistance of this battery cable wire, which is actually kind of a common problem. And one of the things you'll notice right here is if you can see these terminals right here, they're broken, they're frayed, they can become corroded, and these types of things are going to lead you to have a high resistance in your circuit. So if we want to check that, what we're going to do is we're going to go from one end of the wire. The first thing we're going to do is we're going to set up our voltmeter. We're going to put it on the ohm setting, okay? We're going to check and make sure that we have good leads. We want 0. We want to start out with 0, okay, which we started out with 0. So I'm going to place one lead here, and then we're going to go and check the other end of the wire, which is grounded to the terminal. Okay, doing our third test here that we'll be demonstrating. Now that we know that we've got our digital multimeter set to the ohm setting, we're going to go ahead and do a resistance check. Generally, the resistance check is probably one of the first tests that you'll do. To identify if you've got good continuity within your circuit. One of the things you'll notice commonly with batteries is battery cables will be suffering from a lack of maintenance, so it'll be high corrosion, or in this case you'll see broken wires off. These types of things will lead to poor resistance. So we'll go ahead and we'll test the ohm meter, and what you're going to be looking for is in a perfect world you're going to be at 0 ohms. But depending on the serviceability of your leads, you may have a little bit of resistance. If you do have some, you want to be able to subtract that out from your final reading. In this case, we have 0, so we're good. So we're going to go ahead and we're going to check the wire from the starting point and then the actual grounding point, which is the frame. Okay, and as you can see here, we have 0 ohms, which is a good continuity in a good circuit. But however, you know, an example is if no, scrap that. The fourth and final test that we're going to demonstrate today is going to be how to do an amperage test. To do an amperage test, the easiest way to do it is going to be to use an inductive clamp that is incorporated with your...
No.
The fourth and final test that we're going to demonstrate today is how to do a simple amperage or current test. To do that, you're going to want a digital multimeter that actually has an inductive clamp incorporated with it. Once you've got that and it's set up, which it is, you're going to find a source that you want to test. So in this case, we're going to check this how much amperage is going through this battery cable. Right now, as you can see with the key off, there is no current that's flowing through it. But as soon as our demonstrator starts turning over the vehicle, the key's on, we're starting to get some amperage movement. Go ahead and turn it over. Okay. It's dead. Okay. So, as we just demonstrated, when the demonstrator turned the key to the on position, we actually got some amperage movement. But however, when he continues to try to turn it over, okay, we're not getting any amperage movement anymore. And the reason for that is because this battery is not in good health. And as you can remember, when we started out doing this particular test, and we started with our source voltage, we had 12.05 volts, but you can see even during this short period of time that we have actually fallen below 12 volts. That is actually preventing this particular vehicle from, or at least contributing to it from not starting over. So the next step will be to actually do a test on this battery. Thank you.
Good morning, my name is Joseph Wilson.
Oh. 1 0.
Good morning, my name is Joseph Wilson with JTech Students. Today we're going to be talking about tracing the current flow of remote control mirror circuits. In this case, we're going to trace the part of the mirror is going to be the left side, the directional. It's also going to be the left side. What that means to you is that I'm using also my diagram right here. What this means is that when we operating on the select switch is going to be on the left side. So when you go right here, everything on the left is turned on, and on the right side is off. The switch off there also as well, and then left up is on. Now let's look at this diagram right here. This orange represents power, and the motor, which is the load, that's the one where the receiving the power is going to. The green part represents the ground. You got to have that in order to have a good complete circuit. Now, along with that, once you press left, everything on the left side here on the select switch is going to be turned on, right? Which allows you to control the left side or left down if you wanted to down the road. So now, with that said, you have your legend right here, power, load, and ground. So that way it allows you to identify, how everything works. Green, ground, and so on. So, and cut for a second.
0.
Now, one of the things that also that we need to do is basically, when you look at right here, the terminal, they talk about voltage drop. And we have certain sections, E38 and E36. What that means is that it gives you the location on how to check for the voltage. Now, when you say E38, so E3 is this whole section right here. Now, when you look for 8, that is where the positive side of the battery, and you want to test it to the E36. So now what you're gonna do, that is the 6th part right there. To find out what the 12 volts come from, what you're gonna do, one lead is gonna go to the E38, and then E36, now that's the connection, that's where you put your leads and stuff, and you should come out with 12 volts. Now, you're gonna be using this, what we call the multimeter, all right? And that's how you test for the voltage. One more example, right here, the 13.1 to 13.2, if this device right here, when you do that, it's same thing. You're gonna look for the 13.1 area, which is this right here. You're gonna put one lead there, and to the 13.2, boom. All right, you should also have that 12 volts thing also there as well. So 13.1 in case, I'll show you right there. 13.1, you got power, and then you got your load right there. You're testing that, you should have that 12 volts also as well. And that's just one of the main examples out there. You can basically do your troubleshoot for the voltage drop. Once again, my name is Joseph. We talk about the remote control mirror circuit. We talk about the diagram, the power flow, and what is using the power there, which is you have the power, you have the load. Load is pretty much the motor that's taking all the voltage required to operate that device machine, and the ground to be able to complete the whole circuit. And thank you for your time. My name is Joseph with JTech.